All right, good. Welcome back. Welcome back to this YouTube channel. So in the last video, we have actually done a project. Like we just walked through a previous project that I have made. Right. So in the last video, we have did that. So in this video, we're going to get back to this sequential modeling. We're going to like actual sequential modeling. We are not we are done with images now. For now, right? So in this video is all about how can computers understand text, right? So we are actually going to first throw as a problem that that people faced like way back, I think 2016, 2000, like way back probably 2014 or something, I don't know. But this is a problem that they have faced in terms of word model, how to model text. It's how to build language models in terms of text. It's like now if you look at language models like ChatGPT. So this era is all about language models. Like there has been some tremendous progress in terms of language model, in terms of like computers are actually understanding text. Like it just blows everyone's minds, like multi-modeling and all that. So we are going to get back to the roots to actually how they started, right? So what are the ideas, the basic ideas that have led to this much revolution in terms of artificial intelligence. So we'll just go through this. So first, you have learned about language modeling. You have learned sequential modeling. You have learned about sequential modeling, like how we can build models that can find features between these sequence, how they can predict the next sequence. Let's say, I mean, later. Right, sorry for that. So yeah, like you have learned about how sequential modeling works. How can we model between the sequence? How can we find the relation between these sequences? So in this video, we are going to see how can we represent text. You might know, you might have guessed now by now that even text can be considered as a sequence. Like if I am able to generate my text, generate what I'm speaking, then there is some type of patterns or some type of features between these words. Not just understanding what these words mean, but also like the sequence of these words. The past word will determine my current word, and the word that I probably would have told way earlier might have influenced my current word. So that is why there is features between these words, and we can model. There is the chance of or the ability for models to be built, to be able to understand relations between this text. So we can be able to model this language, model our speech, let's say. So first, as you might have guessed the problem by now, the problem is how can we convert this text into some understandable numerical like representation. So how can we represent this text, right? So let's say with each word, how can we represent each word into some type of understandable words, right? So let's say I'm just going to give some examples. So you might get some recommendations. You might give me some recommendations, right? So let's say I say uh I say I am Joel, sorry. Or let's say I say I am a programmer, right? And then let's say I have two sentences. uh Machine learning developer. Sorry for my handwriting. So let's say we have these two sentences in our training set. Let's just keep it simple for now. So how can we represent this text? You might just say we can just represent I as one, right? So we can just say I as one, and we can say M as two, we can say A as three, and we can say programmer as four. And then we have one here. We have actually put that. So we actually created a dictionary. So let's say we give something for machine learning, right? This is 5. This is 6. Yeah. So you might say, yeah, we have solved. We might say we have solved this problem, but we haven't actually. Sorry for that. So you might say, yeah, the problem is solved. We can just represent text as some numbers, and hopefully neural network can be able to find some features between those numbers. You might say, but this is actually not a very good answer. It is actually very worst answer. Because if let's say if you are building a neural network, and um, let's say you have a salary, or let's say you have experience versus salary model, a simple model. Given the experience, predict the salary of a employee, let's say. So let's say that is our problem, machine learning problem. So you might expect that similar experiences, similar number of years of experience, similar values will have similar outputs, right? So that is the actual. So that is actual uh, performance of a neural network, the not natural feature of a neural network to be able to be actually give equal outputs to equal inputs. So like that is a thing. But now here there is no understanding. There is no there is no understanding of what these features are, what this word represents. The model cannot understand what that word means. Yes, it can understand the like very minute relations between these words, but it cannot actually understand the word. So there is no actual representation. Let's say this programmer. So let's say this word programmer and the word developer, they are very much related. So how about we can develop a model in a dream world? Let's say we can develop a model. So our goal is to develop a architecture, or develop an algorithm that can actually give similar values to both the words programmer and developer. So based on the training set, based on the values that I've already seen, we're going to have like huge amounts of text. So when we train our model on this text, it should able to understand that the word programmer and developer is, they are quite similar. So we want our model to actually give similar values to both the words programmer and developer, or programmer and machine learning. That is our goal, right? So that how can we do that, right? So we should actually give some representation to each word, and then these representations should actually make sense. And the distance between so let's say equal representations. So or words that are similar should have similar representations. So that is our goal. How can we do it? So if we think about it, for some time, uh, researchers in this very past have come to this idea of word embeddings. Right? So they will actually develop something called embeddings. So each word will have some representation which we cannot understand, right? And then these representations are do make like computer understand what a specific word means. So how does this word embeddings work? I'm just going to go through it. Right, I'm just going to down. Good. So how does this word representations embeddings work? So the basic idea of neural network is actually the idea of optimization. Right, so what we'll do is we'll just for each word. So let's say I have a word corpus. Corpus is nothing but all the words that are present in that, let's say, the training data set. So we'll have this training data set, and we'll have a lot of words, right? And this is actually a corpus. So for each word, we're going to have, let's say, some metrics associated with each word. So first we are going to have random numbers. We are going to have some random numbers. For each word is going to have some random numbers, and then we are going to optimize these numbers in the training process. So that is actually a very good idea. We'll just have these values, and then using gradient descent, right? So we're going to use some optimization algorithm. So the basic idea of neural networks, the basic meat of this neural networks is actually the idea of optimization. So we are going to run this optimization algorithms in this, right, in these values. So we are going to have this variable values, and then we are going to, based on like getting the least loss for each problem, we are going to update this embeddings. So that actually is a very good idea. So with respect to the problem we are solving, we are going to get this word representations, which is actually a very good idea. So we're going to have this representation, some vector of some values, and then for each word we are going to have some specific fixed number of matrix containing some values. First we're going to have random values, and after training for a very long time on a very huge data set, we'll hopefully get through some vectors which are which are pretty understandable, and which do make sense. So that is the idea of word embeddings. If you want to run word embeddings, you can just create a new layer. So let's say why you are building sequential layers, sequential API to build layers, TensorFlow sequential API. You can just say tf dot keras dot layers dot embedding. So you can just run this small function, and then you have some inputs here. So if you just use this inputs and use this function, and of course include some hyperparameters, I think you can be able to use this embedding. So first you can just input this embedding, and then you can just get this words, and then create an embedding, and then update this values. So that's it for today's video. For this video, thank you for watching, and I'll see you in the next video. Thank you.